Okay students, let us try to solve this question. It says like you need to calculate the energy which you require for the process. And what is the process? Process is you are given He plus in the gas state, helium ion. Now from here you need to remove one electron in order to form He2 plus. Okay, so you know that the process of removal of electron is referred to as an ionization energy. So we need to find out the ionization energy which is required to do this particular process. And you are given the ionization energy of hydrogen atom in the ground state as 2 into 10 to the power of 2.18 into 10 to the power of minus 18 joules per atom. This is given to you. Okay, and you have to find out the ionization energy required to remove an electron from He plus ion. Okay, so how do we do the solution for this? Students, we are aware that energy for nth orbit of atoms like that of hydrogen, right, of atoms like hydrogen that is containing one electron in them like H, He, Li2 plus, etc., is given as En is equal to minus 2.18 into 10 to the power of minus 18 divided by n square into Z square joules per atom. This is known to us. This formula is known to us. Okay. Now for hydrogen atom, you will have Z is equal to 1 and your N will be equal to 1, where Z is the atomic number of hydrogen and N is the orbit. We are knowing that electron is there in the first orbit for hydrogen. Okay, so actually here therefore your energy 1, that is energy in the first orbit, will be 2.18 into 10 to the power of minus 18 divided by 1 square into 1 square. So this ends up in value of energy given to you as minus 2.18 into 10 to the power of minus 18 joules per atom. Okay, so this is the energy of the first level. Now student, actually they have given you the ionization energy for hydrogen atom. Now what do you mean by ionization? Here they have given you as 2.18 into 10 to the power of minus 18. So here ionization energy, if you want to find out for hydrogen atom, then delta E would be del E at infinity, energy at infinity minus energy at the of the first orbit. Now students, we know that for suppose this is your first orbit and electron is there in the hydrogen atom here, and you need to remove this electron. Obviously this electron will be going somewhere out when you are talking about ionization. Okay, so somewhere here whatever energy you will have at this infinity level, you subtract it from the energy at the first level. So you will get the energy which was required. When you subtract, you will get the energy which is required to remove that electron. Fine. So we know that if you put up the value of E infinity energy formula here, same. So you will have minus 2.18 into 10 to the power of minus 18 divided by infinity square into Z square. Okay, this you will have minus the energy E1 which we have just now found out. You will get minus 2.18, here we have found out, into 10 to the power of minus 18. Okay, so something divided by infinity square will be giving you value 0. So 1 divided by infinity square will be infinity, and 1 divided by infinity would be 0. The full term in the numerator when divided by infinity will be 0. So here you will have 0, minus and minus will become plus. So ultimately you will have energy as 2.18 into 10 to the power of minus 18. So that is your ionization energy given to you. Already this is given to you in the question. This 2.18 into 10 to the power of minus 18 which was given, that was for hydrogen atom. Okay, the ionization energy which was given to you could be found out by this particular formula which they have already given to you. you get back 2.18 into 10 to the power of minus 18 joules per atom. Fine. Now what you need to find out is, during the process of removal of electron from He plus, what energy will be required. Now here let us try to solve for helium. So for ionization of He plus to He2 plus electron. So what will be the change, that is ionization energy you will require. Here also you will see that you will subtract the energy level 1 from energy level infinity, because helium is having plus 1. The electron here is 1s1, it is in the first orbit itself, and that's why we take minus 1. So electron from the first orbit here will be going to your infinity level. So you see the change in the energy will be the ionization energy required to excite this electron to infinity level. So now if you try to find out this delta E, which they have asked you in the question, that this is the main question they are asking you to find out. Fine. Now as I told you above, your E infinity would be your 0 minus of the formula you are having of E here, which I generally told you, En1 minus 2.18 into 10 to the power of minus 18 divided by, I told you the formula has n square in the division. So n square here is the orbit number. So 1 square into, now here we are talking for helium ion. So Z would be atomic number of helium, that is 2 square. Okay. So here you will have this minus would be plus. So it would be 2.18 into 10 to the power of minus 18 into 4. So ultimately the ionization energy which you get to form He2 plus from He is, you just multiply this 4 with 2.18. It will be 8.72 into 10 to the power of minus 18 joules per atom. So that is the answer for this particular question. Students, let me tell you that this particular part which we have just now found out, ionization energy for He2 plus, can also be found out with the direct formula. Let me show you that how you can do. Okay. So or you can directly take the formula as delta E is equal to 2.18 into 10 to the power of minus 18 Z square divided by N square and 1 by Ni square minus 1 by Nf square, where your Ni would be your, here Ni would be your 1 and your N final would be your infinity. So just if you put up the values and solve, 2.18 into 10 to the power of minus 18, Z is the atomic number for helium, as we are talking and wishing to find out for helium, it would be 2 square divided by, it is in the first orbit, electron, so 1 square. And now here as I told you, Ni value is 1 square minus 1 by infinity square. Now you just try to solve this, it will be 2.18 into 10 to the power of minus 18 into 4 divided by 1. In the bracket you will have 1 minus 1 by infinity square is 1 by infinity, which is equal to 0. So 1 minus 0 would be 1 only. So you are left over with 2.18 into 10 to the power of minus 18 into 4. Multiply this value and you will get 8.72 into 10 to the power of minus 18 joules per atom. See, the answer which you are getting is the same in either of the ways. Just have a look, we have just now found out this answer here, here and here, they are the same one. So either way you can do this particular sum. So just have a look how this particular question is solved for you. I hope it is understood. Please keep on revising so as to understand the question nicely. Thank you all.